Hey everyone, Mike here from Arnold Tutoring. In this video we are going to review a little bit about quadratics and sort of how some of their basic properties change depending on the equation. So here we're asked to find the domain, range, and the min or the max of a certain function. And that function is y equals 6x squared minus 36x plus 11. First thing to notice is that it is in fact a quadratic, even though it doesn't say so in the question. We know it's a quadratic because its highest power on an x is 2. So we have x to the 2 there with a 6 in front of it, so we know it's a quadratic function. I'm going to talk about domain first, and I want to talk about it in two different ways. First, just algebraically, how we find the domain, and then secondly, if we can think about how this quadratic, or quadratics in general, how they look on a graph, we can easily see what the domain is going to be. So, domain, what does that mean again? Well, domain is the set of all x values that are found in the function. In other words, which x values, so algebraically, which x values can we plug in to this function for x, so which numbers can we put in for x, where we would actually get an answer out for y. In other words, I know, for example, that I can put 1 in for x, because I can just replace x with 1. 36 times 1 instead of x, plus 11. I've just replaced, I've picked 1 as a particular x value, replaced it, and what will we get? 6 minus 36 is negative 30, plus 11 would be negative 19. So I got an answer out for y. Now, if we think about this equation, it's just a polynomial, right? Y equals 6x squared minus 36x plus 11. So any number we've ever heard of, decimals, fractions, or integers, we can plug in for x there, multiply it by, or square it, and then multiply it by 6 here, multiply it by 36 here, and add 11 onto it, and we'll get some answer. Which means the domain is x is an element of the reals. This is normally how we write it. Which means x can be any single number. We can plug in any number for x there, and we'll get an answer out for y. Now let's quickly think about it in a graphical sense. We know that any quadratic is a parabola, so it's either going to look like this or look like this, shape-wise, right? Now both of those, you can see these arrows on the end, that means they're going to keep going in those directions forever. So they'll keep going to the right and keep going to the left on either side, and it's a continuous function. There's no break in the function, so that means it's going to go as far left as you can imagine and as far right as you can imagine for across the x-axis here, which means it's going to cover every single number for x. So hopefully that gives you a good sense of how to determine domain. You can just think of it as, are there any numbers that I cannot plug in for x? And if there aren't, then our domain is x as an element of the reals. Let's talk about range really quick. So range is a little trickier. Range is, are there any restrictions, essentially, on the values of y that can be found? So this one's easiest to look at graphically again, because if we think about this red function here, and we're going along the y-axis, remember, so the vertical axis here, the red parabola keeps going upwards from this point, which is its minimum. So it starts as its minimum and it goes upwards forever, which means it covers every single y value above the minimum. For the orange one, it's the exact opposite. We have a maximum value here. The parabola opens down, but it's going to go down forever, which means it's going to cover every single y value. Remember, y is along the vertical axis. It will cover every single y value that's less than this maximum point. So, all we have to do is kind of skip ahead to our, what the question asks for is min-max, figure out where that is, and whether it's a minimum or a maximum on this particular quadratic, and then we can determine our range. So, to determine the min and the max of a quadratic, the easiest way is to get it into vertex form, which requires completing the square. So I will do that as a review. We have other videos on this as well, but I'll run through the steps here. We're going to take -6 divided by 2, which is -3, and square it, so that'll be plus 9. So we want plus 9, but you can't just add 9 in without creating an imbalance, so you also have to subtract 9, and you still have the plus 11. The reason we did the 9 was because that will cause a perfect square of x minus 3 squared. We have to do the 6 out front here, multiplied to the -9 to bring it out of the bracket, which is -54 plus 11. So your final equation in vertex form is y equals 6 into x minus 3 squared minus 54 plus 11 is minus 43. So, a couple characteristics to review for a quadratic. This is in vertex form. The fact that this coefficient in front of the squared term is positive, that means it opens up, just like the red function right here. So we know functions that open up or have that positive coefficient, they're going to have a minimum value. See how there's a minimum value that it sort of bottoms out at, and then every other y value is above it. That minimum y value is found here in the function as well at -43. So we can say the minimum of this function, the value is -43. When we're asked for the minimum or maximum value, we just give the y coordinate. The x coordinate also happens to be 3. Since -43 is our minimum, and we know every other y value greater than that is in our range because of the characteristics of a parabola, we can say that the range is y is an element of the reals, so it's in the real number set, where y is greater than or equal to 43. -43, sorry. Because we know that's where it bottoms out, and it's going to cover every single value above that. So that's a quick review of domain, range, and minimum and maximum. Again, the minimum and maximum, I went fast when completing the square, but we have other videos on that. The key is to keep in mind the characteristics of a parabola. So they'll either have a minimum value if it opens up, or a maximum value if it opens down. What dictates it, whether it opens up or down, is the fact that the coefficient in front of the squared term is either positive, it'll open up, or negative, it'll open down. And again, domain is just which x values can you plug into the function to actually get a value out for y. Hopefully this is clear. You can always send us more questions, info@arnoldtutoring.com, and good luck with your next domain and range question.